Hello students, in this video we are going to discuss remaining objectives from practical number 1. Ninth objective is H chromatic number of Peterson graph is. So first let us draw Peterson graph. I am drawing here Peterson's graph. This is Peterson graph. Peterson graph. We want to find H chromatic number of this graph. So let us color the edges by giving color 1, 2. I can give color 1 to this edge, color 2 to this edge. I cannot give color 2 to 1 and 2 to this, so I am giving color 3 to this edge. 1 and 3 is assigned to these two edges, so I can give color 2 to this edge. Again 3 to this edge, 1, 2, 1, 2, 3, 1, 2, 3, 1, 2, 3, 2, 3, 1. Now let us color the internal edges. Color 1 is assigned here, color 3 is assigned here, so I can give color 1 to this vertex, color 3 is assigned here, 2 is assigned here, this edge and this edge. So first let us rename these vertices as A, B, C, D, E, F, G, H, I, J. You can observe J, H and F, I. These are non-adjacent edges. So I can give color 1 to J, I also. Similarly, these two are non-adjacent. So this edge J, H is colored with color 1. F, I is colored by using color 1. Now let us color J, G. So J, G. 3 color is assigned here, 1 color is assigned to GD. So we can color GJ by using color 2. Now JH has assigned color 1, JG has assigned color 2, FI has color 1. Now FH remains, FH. So EF has color 2, HC has color 3, so we can color FH by color 1. We cannot use color 1 to FH because JH has color 1. So we cannot use color 1, 2 and 3 to FH. So we must have to use color 4 to FH. And the only H remains is GI. We cannot assign color 3 to GI. Similarly, we cannot assign color 1 to GI and 2 to GI. So we have to use color 4 to GI also. Now let us check where GI and FH are adjacent. No, GI and FH are not adjacent. So we can use color 4 to color edges FH and GI. So by using 4 colors we have colored Peterson graph. So H chromatic number of Peterson graph is 4. Now second 10th MCQ is H chromatic number of K57 is. We know that chi dash of Km comma n is equal to delta G. What is chi dash of Km comma n? That is H chromatic number of bipartite graph. H chromatic number of bipartite graph is equal to, what is delta G? Delta G means maximum degree of graph G. H chromatic number of bipartite graph is maximum degree of G. That means a vertex with maximum degree. If you consider K57, then maximum degree is equal to 7. So our H chromatic number of K57 is 7. By drawing graph K5, you may count H chromatic number of K57 is 7. But we have used this theorem and we get H chromatic number of K57 is 7. Now next MCQ is H chromatic number of cycle on 2n vertices is. So let us draw a cycle on 2n vertices. So I have drawn here cycle on 4 vertices, that is C4. 2n vertices mean number of vertices in cycle should be even. And I am drawing C6. Let us see what is happening to C4 and C6. Let us color the edges. I can use color 1 here, color 2 here, color 1 here and color 2 here. A, B, C, D, A, B, C, D, E, F. Similarly, we can give color 1 to AB, 2 to BC, again 1 to CD, 2 to DE, 1 to EF and 2 to AF. This coloring is proper. So we can say H chromatic number is 2. You may observe here n is equal to 4, but H chromatic number is not equal to 4. N minus 1 is 3, but H chromatic number is not equal to 3. So option A is incorrect, option B is incorrect. Similarly for C6, we are not getting H chromatic number 3, or for C4 also we are not getting H chromatic number 3. So option A, B and D are discarded. And by drawing C4 and C6, we have observed that H chromatic number on even number of cycle, H chromatic number of cycle on even number of vertices is 2. If G is a, next MCQ is, if G is a K critical graph, then G is, this is a standard theorem. If G is a K critical graph, then G is connected. We have discussed this theorem in our classroom. So we can easily conclude that G is K critical, then G is connected graph. So let us discuss another MCQ. A graph that has H chromatic number 1 is Kn n greater than or equal to 2. Here we have given n greater than or equal to 2. So let us draw K3. If I draw K3, then H chromatic number is 1, 2 and 3. That is not equal to 1. So option first is incorrect. Cn. You can see the same graph. K3, that is C3. It has H chromatic number 3 and not 1. So Cn also incorrect option. If you consider K2, number 1. So option C is correct option. And option C is correct option. So also incorrect option. Next objective is H chromatic number of K1n n greater than or equal to 2 is. Okay. So let us draw here given n greater than or equal to 2. So I have again pi dash of K12 is equal to 2. Now let us draw K13. So we can use color 1 to this edge AB, CD. If we color AB by color 1, then we cannot use color 1 to color AC. So I have assigned color 2 to edge AC. Now 1 and 2, both colors cannot be used for coloring of AD because AB, AC and AD are adjacent edges. So chi dash of k13 is equal to 3. So similarly, if you consider k1n, then we have to use n different colors because all edges, suppose this is v1, vv1, vv2 and so on vvn. Edges vv1, vv2 and so on vvn all are adjacent edges. So we have to use n distinct colors for coloring of edges vv1, vv2 and so on vvn. So in general, edge chromatic number of k1n is n. Now let us discuss another objective. C be a proper edge coloring of G, V, E using T colors, then the coloring partitions E into. That means we have given G is a graph on V vertices, E edges, and edge chromatic number of graph G is T. Chi dash of G is equal to T. Then the coloring partitions, C is a proper coloring. That means suppose we have used T colors 1, 2 and so on T to color edges in graph G. Then we can partitions E into. Already we have discussed this in our classroom that if we use T colors, then the edge set is partition into T set. How we make this partition or how we create this partition? So we consider set say A1, where A1 contains set of edges with color 1. Set of edges in G colored with color 1. A2 is set of edges in G with color 2. So on, AT is set of edges in G with color T. With color T. If you take union of all these T sets, you will again get set. So union of AI, I running from 1 to T, you will again get set of all edges in graph G, and A1 is set of edges with color 1, A2 is set of edges with color 2, and we cannot assign same color to any edge. That means we cannot assign color 1 as well as color 2 for any edge E. That means A1, A2 and so on AT all are pairwise disjoint set. So A1, A2 and so on AT is clearly a partition of edge set of G. That means if we have T colors to color edges in graph G, then we can partition the edge set into T parts. Next objective is edge chromatic number of a bipartite graph X, Y, E is. Already we have discussed this example. Chi dash of KMN is equal to delta G. Instead of asking for KMN, they have given bipartite graph. But bipartite graph, KMN is also bipartite graph, but it is complete bipartite graph. But for any bipartite graph, edge chromatic number chi dash of K, chi dash of G, bipartite graph G, chi dash of G is equal to maximum degree of G. And for bipartite graph, if cardinality of bipartition X and Y, we don't know what is cardinality of X and cardinality of Y and which number is largest, but largest of cardinality X and cardinality of Y will be maximum, will be the edge chromatic number of graph G. So maximum of cardinality of x, cardinality of y will be correct option. H chromatic number of a bipartite graph is maximum of cardinality of x, cardinality of y. 17th, H chromatic number of a complete graph Kn is. Already we have discussed this theorem. Chi dash of Kmn is equal to, we are considering Kn. So chi dash of Kn is equal to n if n is odd and n minus 1 if n is even. We have discussed this theorem in our classroom. So this exactly n is incorrect because n chi dash of kn is equal to n if n is odd, n minus 1 if n is even. So option C is correct option because we have not given any condition on n. They are asking for kn, so it will be either n or n minus 1 depending on n is even or odd. Last MCQ is, if H chromatic number of a graph G equals to maximum degree of G, then G is. Okay. So we have cycle. So let us define for cycle. H chromatic number of graph G equal to maximum degree of G, then G is. Okay. So I have considered this cycle. We have given color 1 to edge AB, color 2 to BC, 3 to CD, 1 to color 1 to CD, 2 to ED. Now we cannot assign color 1 and 2 to EA. So we must have to use color 3 to color edge AE. So chi dash of C5 is equal to 3. So here maximum degree delta of C5 is equal to 2, but chi dash of C5 is equal to 3. So H chromatic number is not equal to maximum degree for cycle. So cycle option is incorrect option. So bipartite graph and tree. So it can be happen to bipartite graph. H chromatic number of a graph equal maximum degree of G. Already we have discussed this theorem. If G is a bipartite graph, then chi dash of G is equal to delta G. So B option is correct option. Also every tree is a bipartite graph, so option A is also correct option. So A and B both are correct option for 18th MCQ. So we have discussed all the objective questions from practical number 1. In our next video we are going to solve another examples from practical number 1. Thank you.